Hey everyone, welcome back on IB Physics with Vaibhav sir. In today's video, I have complete detailed solutions of IB Physics HL paper, May 2025, time zone 2. And in this paper, we'll walk through all the 40 questions step by step, one by one, with full detailed solutions so that you'll understand that why the correct answer is correct and not just what the correct answer is. So if you just attempted this paper, this video is for you. So without wasting any time, let's get straight into it. So this is Physics HL paper 1A, May 2025, time zone 2. So let's start this paper. So you can see that in this first question, there is a ball which is initially at a height of 50 meter above the ground. And this ball is thrown vertically upwards and it takes 5 seconds to reach the ground. The air resistance is negligible, so we have to find out the initial speed of the ball. So it is a simple scenario, and we can see that if this is ground, the ball is thrown from this point, which is already 50 meter above the ground level. This ball is thrown with the velocity of u. Now it goes like this. Okay, and you can see that the initial point is this and the final point is this. So the displacement of the ball is minus 50. This minus is due to the fact that the final point lies below the initial point. This is initial point, this is final point. And you can see that the final point lies below the initial point. Therefore, the displacement of the ball will be minus 50. The acceleration of the ball will be minus g, which is 10, and the air resistance is negligible. U is in upward direction, so we will consider U as positive. So we can say that according to the second equation of motion, S is equal to ut plus half at square. S is minus 50. U is unknown, which we have to find out. Time is 5 seconds, so this is 5, and minus half g is 10, and this is 25. Okay, so you can see that it would be equal to 125 minus 50. So 5u will be equal to 125 minus 50. So it is 75 and u will be equal to 15. So the correct answer of this question will be B. Now let us move on the next question. In this question, you can see that there is an object which is sliding from rest down on an frictionless inclined plane. The vertical displacement of the object is 1.5 meter during the first second. So what is the vertical displacement of the object during next second? So it is quite simple question that you can see that you do not have to take any angle or you do not have to consider the acceleration on inclined plane. Just you can do that in y direction, which we are considering as vertical direction. So in y direction, we will apply S is equal to ut plus half at square. Okay, and you can see that obviously initial velocity was 0. It is starting from rest. So during first second, it moves a distance of 1.5. So 1.5, I am considering that the downward direction is positive because there is no vector which is initially in the upward direction. So we can consider the downward direction as positive because all of the quantities like displacement, acceleration are pointing in the downward direction only. So we can consider the downward direction as positive. So 1.5 will be equal to ut. Now u is 0 obviously, and this is half g is in fact we do not know the acceleration, so we assume that it is ay. See, actually, you know that the acceleration of this block on this inclined plane will be g sine theta, and there would be a component of g sine theta in vertically downward direction. So we are just ignoring the trigonometry involved in that component. We are just considering it as ay. Now the time is 1 second, so it is 1. So you can see that ay will be equal to 3. Now we have to find out that will be the vertical displacement of this block in the next second. So what we'll do, we'll find out the displacement in 2 seconds minus the displacement in 1 second. So this will give us the displacement in second. So in 2 seconds it would move half ay into 2 square minus in 1 second it would move half ay into 1 square. And already in one's first second, we already know that its displacement is uh, 1.5. So it is half ay is 3, and this is 4 minus this is 1.5, which is 3 by 2. So this will be equal to 6 minus 3 by 2. So it is 12 minus 3 by 2, which is 9 by 2. So it is 4.5 meters. So the correct answer will be option C. Now let us move on the next question. In this question, you can see that this is a trajectory of a ball which is launched from this point. This is the highest point Q, and this A represents the direction of acceleration of the ball at the highest point. This is the impact point where ball will land, and this is the theta angle with the horizontal with which ball will land on the ground. So we have to choose the correct statement when there is actually air resistance present in the motion. So considering the air resistance, we have to choose the correct statement. So if there is air resistance, then Q will be lower. This is obvious because Q is the height of the maximum point of the highest point from the ground. It is the highest point. So obviously this point will be lower because there will be loss in energy due to air resistance. So this point will be lower. So we can say that Q will be lower. This is correct one. A remains same. See, when the ball will move to the highest point, then its acceleration will be g in the downward direction, and it is also g in this case. So this a is obviously a vertical acceleration. So there will be a horizontal acceleration also. See, when the ball will be moving in the presence of air resistance, then at the top point, its velocity will be only in x-axis. So there will be a horizontal resistance which is due to the air resistance, and there will be a vertical resistance which is g. There will be no component of resistive force in y direction at the top point because Vy is 0. You always know that air resistance will always act when the body is moving, and it always acts in the direction of which is opposite to the velocity. So here the velocity is in x direction, so air resistance would be acting in the minus x direction. So the vertical component of the acceleration at the top point will be g only. So second is also correct. And now if we consider about theta, so you can see that let us suppose this launch angle is 45 degree. Okay, and if this ball has no air resistance in the path, then this angle would also be 45. This we all know that in the absence of air resistance, ball reaches the ground at the same angle at which it is projected. So this would also be 45 if there would be no air resistance. But we have to analyze the situation in the presence of air resistance. So let us consider that there is air resistance, and let us see that if the angle of projection is 45, then we can say that ux, the x component and the y component will be same because projection angle is 45 degree. Okay, so at this point, obviously you can see that there will be a continuous air resistance which is acting in the backward direction, which is retarding this velocity u. And there will be a y resistance, a y component of air resistance also, So it would be retarding this component u. But at the top point, u will become 0. Now, just analyze the motion in the downward journey. When the object will be moving in the downward direction, then the acceleration due to gravity will be accelerating it in the downward direction, and the air resistance would be retarding it in the upward direction. So there is some acceleration which is also accelerating or also increasing the speed, along with the acceleration which is decreasing the speed in the y direction. But if you consider the x direction only, then there is only single acceleration which is continuously decreasing the x velocity. So we can say that at this point, the velocity vx and this is vy will not be same, obviously, and tan theta will be equal to vy by vx. Now, we can easily say that both of them will decrease as compared to the previous case, but the decrement in Vx will be more as compared to Vy, because Vy is being accelerated by g and it is being retarded by Ay, and Vx is continuously retarded by Ax. There is no accelerating force in the x direction. So Vx will decrease more, and therefore we can say that the angle with which it would reach the ground theta would increase. So this is also correct. So the correct answers would be 1, 2, and 3, and therefore the choice which is correct is D. Now let us move on the next question. In this question, you can see that there is a car of weight W. It is traveling at the maximum speed in the circular path along the horizontal banked road. The surface exerts a normal force, friction force, and we have to draw the correct free body diagram. See, we know that if the car is moving at the maximum possible speed, then it would have a tendency to slide in the upward direction like this. So if there would no friction, then this car would have slided in the upward direction. Therefore, the friction we can say will be acting in the downward direction along the incline. Normal reaction will be acting like this, and weight will be acting like this. So you can choose the correct option, and it would be D. Okay, now we move on the next question. In this question, you can see that there is a sphere X that falls through a fluid with velocity V. Okay, and the sphere Y is made up of the same material which falls through the same fluid. Now, radius of sphere Y is double as that of X. So, what will be the terminal velocity of Y? So, we know that the terminal velocity is the velocity when the net force is 0. So we can say that when the sphere will be falling, x will be falling, then mg will be acting in the downward direction, buoyancy will be acting in the upward direction, and viscous force will be acting in the upward direction. Okay, so the net force will be mg minus buoyancy, and it would be balancing out viscous force. Now mg will be rho into v into g, minus buoyancy will be sigma vg, and viscous force will be 6 pi neta rv, where v is the uh, velocity and net force is 0, obviously, so we can say that v is the terminal velocity. Now you can see that v is the volume of the sphere, and it was 4 by 3 pi r cube g, and it is sigma minus rho minus sigma, and it is 6 pi neta r vt. So vt is proportional to r square. If you remember this formula, you can write it directly, but I assume that most of the students do not remember this terminal velocity formula. So I have just derived it in a short method. So Vt is proportional to R square. Okay, and the material is same. So obviously rho is same for both of them. So if the first one x has a terminal velocity of v, and y has a radius which is double of x, so we can say that terminal velocity of y will be 4 times of that of x. So the correct answer would be fourth, D. Now we move on the next question. In this question, you can see that there is a flywheel which is initially at rest and it rolls down, slipping on an inclined plane for 4 seconds. The final angular velocity of this flywheel is 5 pi radians. So we have to find out that how many revolution did it complete. So we will be using this formula, which is omega 2 square is equal to omega 1 square plus 2 alpha theta. Okay, so omega 2 is 5 pi, so this is 5 pi square is equal to 0 plus 2 alpha theta. But obviously alpha is unknown, so we would also use this formula. Omega 2 will be equal to omega 1 plus alpha theta, alpha t. So omega 2 is 5 pi and omega 1 is 0. So alpha and t is 4 seconds. So alpha is 5 pi by 4. So we will substitute this value here. So it is 25 pi square and it is equal to 2 alpha. Alpha is 5 pi by 4 and this is theta. So this is 2, this is 5, this is pi. So theta will be equal to 10 pi. Now this is the angular displacement. We have to find out the number of revolution. So number of revolutions will be equal to theta by 2 pi. So there are 5 revolutions. So the correct answer is 5. Now let us move on the next question. In this question, we have to pick the correct unit of angular impulse. So angular impulse we know is linear impulse or change in angular momentum. So angular impulse is equal to mvr. So the unit of angular impulse will be mv, and this is also equal to delta angular momentum. But you can see that we have to choose the correct unit in terms of Newton. So we know that torque is equal to dl by dt, and dl will be equal to tau dt. Torque is Newton meter and dt is second. So the change in angular momentum, which is also the angular impulse, has a unit of Newton meter second. So the correct answer is D. Now let us move on the next question. In this question, you can see that there is a car of total mass m which is traveling with a constant speed of v. Each of the four wheels of the car has a mass small m and a radius capital R, and they roll without slipping. The moment of inertia of each wheel is this. So we have to find out the sum of rotational energy of all four wheels upon the translational kinetic energy of the car. So the rotational energy of all four wheels will be 4 times of half I omega square. Okay, and omega will be equal to V by R. So this is 2 into I. I is half m r square and omega square is V square by R square. So this is mv square. Okay. Now translational kinetic energy of the car. So K translational will be half into mv square. This is the kinetic energy of wheels, translational kinetic energy, into 4 plus the total mass. In fact, the total mass of the car is m. So we can directly write it as half m v square. Okay, so the ratio of the rotational kinetic energy of the wheels upon translational energy of the car will be 2m by m. So the correct answer will be C. In this question, you can see that there are two spherical black bodies X and Y. Okay, and it is given that the absolute power radiated by X is half of the total power radiated by Y. So we have to find out the radius of Y, and it is also given that the radius of X is R and the absolute temperature of X is double of that of Y. So first of all, let us see the formula which is used in this question. That is sigma E A T to the power 4. And for ideal black bodies, E is 1. So power will be sigma A T to the power 4. Now, if these black bodies are spheres, so we can say that the area will be 4 pi r square T to the power 4. Now, it is also given that the power of x is half of the power of y. This is py by 2. So, power of x is sigma into 4 pi r square, and its temperature is twice of that of y. So, this is 2t to the power 4, and this is sigma into 4 pi r y square t to the power 4 by 2. So you can cancel out this, and t to the power 4 will be equal to r square into 16 into 2, which is 32. 32 t to the power 4. Okay, and this is ry also. So ry will be equal to root of 32r, which is 4 root 2r. This is 32. So the correct answer will be option C. Now let us move on the next question. In this question, you can see that the albedo of atmosphere above a small region of Earth's surface is 0.25 and the solar constant is S. So what is the incoming intensity of solar radiation that is incident on this region when when the sun is directly above the region? We know that this albedo is the ratio of reflected intensity. This is reflected intensity to the total incident intensity. Okay, so this is given as 1 by 4. You can see that this is given as 1 by 4. So I reflected upon I is 1 by 4. So I reflected will be I by 4. So I transmitted, which is transmitted from atmosphere to earth, will be 3I by 4. I minus I by 4. Okay, and I is obviously solar constant S. So the intensity which is incident on the earth's surface, I am talking about the intensity which is incident on the earth's surface. And that incident intensity is transmitted from the clouds or atmosphere. So it is equal to 3S by 4. Okay, intensity is S. So this is 3S by 4. I am not talking that I is equal to S. Intensity is termed as S. So the correct answer will be C. Okay, we have to find out this intensity only, which is incident on the Earth's surface. Now, in this question, you can see that there is a gas which is held in a container. An ideal container holds, in fact, an identical container holds the same number of more massive molecules of another gas at the same temperature. So, what is true about the density and pressure of both containers? First of all, let us consider the situation. The fact that if we talk about the number of moles, so they are equal to n upon Na, where n is the Avogadro number. Okay, so if you can see that both containers have same number of molecules, then we can say that n is same, number of moles is same. Okay, and temperature is also same and volume is also same. So P V is equal to P1 V is equal to nRT and P2 V is equal to nRT. Okay, now you can see that if volume is same because containers are identical and temperature is same, number of moles are same, then we can say that the pressure P1 P2 will be same. So pressure in the both containers will be same. So these could be the correct answers. And if we talk about the density, so pressure will be equal to M by M RT by V, and M by V is density. So pressure will be equal to RT rho by V. In fact, M. So if pressure is same, then density is proportional to the molecular mass. And obviously, the other container has massive molecules, therefore their molecular mass will be different. So we can say that density will be different. So the correct answer would be C. Now let us move on the next question. In this question, you can see that there is a cyclic process which is shown for an ideal gas. This cycle has three stages. One is isochoric, which is isovolumetric. The other one is adiabatic, and the third one is isothermal. And it is also given that work is done on the gas during the isothermal stage. We know that first of all, this is isochoric, this is adiabatic, and this is isothermal. And we also know that if the work is done on the gas, therefore gas would be compressed. So this is the isothermal stage, and it is in the compression state. So the compression means volume will be decreasing. So this cycle is clockwise, and Z is the isothermal stage. So isothermal, and which is the direction of cyclic process. So the correct answer is D. Now let us move on the next question. In this question, you can see that there is a wire of length L that is used in an electrical heater. When the potential difference across the wire is 200 volts, the power transferred in the wire is 500 watt. A second wire that is made up of same metal and has same cross-sectional area. When a potential difference of 400 volts is applied across the second wire, the power transferred is 2000 watts. What is the length of the second wire? We know that the power is V square by R, and R is rho L by A. So we can eliminate, we can uh, ignore the factors which are same. So A is same, rho is same. So we can say that power is proportional to V square by L. Okay, and initial power was 500, and initial voltage. Let us suppose there is some constant K. K multiplied by V square. V square is square is 200 square, and L is L. Okay. Now the power is 2000 watts and K is K. Now voltage is 400. So 400 square and length is L dash. So let us just now divide these two. So 5 by 20 will be equal to 200 by 400 square, and this is L dash by L. So this is 1 by 4, and this is also equal to 1 by 4 into L dash by L. So L dash will be equal to L. So the correct answer will be C. Now let's move on the next question. In this question, you can see that there are four identical resistors that are connected like this. So we have to find out the value of current in X upon current in Y. So obviously these are identical. So this is R, this is R, this is R, this is R. Okay, and let us consider that the potential difference across X is V. Okay, and now let us consider that current is I, total current is I. The equivalent of these two is R by 2, and the equivalent of these three will be R by 2 plus R, which is 3R by 2. Now, if we divide this current in the ratio of resistances, so what we can do that the ratio is R is to 3R by 2. So it is 2 by 3 ratio, and the current flowing through this X will be 3I by 5, and the current flowing through this will be 2I by 5. Okay, then this current will be divided into two equal parts, so it would be I by 5 and I by 5. So the current in X upon current in Y will be 3. So the correct answer will be 3. Now let us move on the next question. You are dividing this with this. Okay, so it would be 3. Now let us move on the next question. In this question, there is a spring mass system that is oscillating simple harmonically. So we have to find out that which graph represents the variation of acceleration with displacement. We know that acceleration for a simple harmonic motion is minus omega square x. So there is a linear relationship and this would be a straight line. So the correct answer will be D. Now let us move on the next question. In this question, a spring mass system oscillates simple harmonically with the maximum elastic potential energy. The mass is tripled and amplitude is doubled. What is the new maximum elastic potential energy of this system? So the maximum elastic potential energy is half K A square, where A is the amplitude, and it is half K. Now K is constant spring, it is spring constant, and A is the amplitude. So A square. Now mass is tripled and amplitude is doubled. So if obviously mass is tripled but K remains the same and amplitude is doubled, so the energy would become 4 times. So the correct answer will be 4A. Now let us move on the next question. In this question, you can see that there is a transverse wave whose time period is 20 milliseconds, and it is traveling through a medium. Now this graph shows the variation of displacement of particle with the distance traveled by the wave. We have to find out that what is the average speed of the particle during this motion, and what is the direction of particle motion relative to the direction of wave motion. It is very clear from the question itself that this is a transverse wave, and in a transverse wave the direction of particle motion is in the perpendicular direction to the wave motion. So we can say that the option A and option C are incorrect because they are showing the parallel direction. So first of all, this is the correct choices could be B and D. And now we have to find out the average speed of the particle. So average speed is the distance traveled in a cycle. So distance traveled in a cycle is A and then A and then A and then A. So it is 4A, where A is the amplitude and time period is T. So A amplitude is 4, you can see, and it is in centimeters. So this is 4 into 4 into 10 raised to power minus 2, and this is 20 into 10 to the power minus 3. So it is 4 by 5 into 10 to the power 1. So it is 8. So the correct answer will be B. Now let us move on the next question. In this question, an ultraviolet wave is traveling through the vacuum. What is the frequency and nature of the wave? See, first of all, we know that ultraviolet wave is of very high frequency. So frequency could be from 10 to the power 15, these two options. And obviously ultraviolet wave is a electromagnetic wave, so its nature would be transverse. So the correct answer would be A. Now let's move on the next question. In this question, you can see that the fifth harmonic standing wave is formed in a pipe whose length is 25 centimeter and it is closed from both the ends. Now, what what 2 points along with the pipe has a phase difference of pi? So let us consider the situation that there is a fifth harmonic in this pipe which is closed from both ends. Now, if the pipe is physically closed from both ends, then we can say that there would be antinode on the closed ends and it is in the fifth harmonic. So if we consider it as a displacement wave, we can draw the nodes also at the closed ends and you can see that there would be 5 loops because it is in fifth harmonic. So these would be 5 loops and this length of the pipe is 25 centimeter. So we can say that this is lambda by 2 and 5 lambda by 2 is equal to 25. So lambda by 2 will be equal to 5. So this is 5. So we have to identify those two particles which are in the phase difference of pi. So if we consider these two particles, this is 2 and 7 will be in this. So these are in neighboring loops, so they would have a phase difference of pi. 4 and 21, if we consider 4 and 21, this is 4 and 21 would be in the last one. So these two are out of phase, these two are in phase, these two are out of phase and these two are in phase. So it is wrong. Similarly, 7 and 9, the 7th will be in this and the 9th will also be in this. So they have 0 phase difference and 11th and 14th would also be in same loop. Therefore, their phase difference will be 0. So the correct answer is A. Now let us move on the next question. For lightly damped oscillations, amplitude goes 0 within one period of oscillation. The oscillation frequency does not changes with time. Energy is transferred from oscillation as quickly as possible, and oscillation frequency is equal to the undamped oscillation frequency. See, first of all, let us analyze the option A, that it says that amplitude goes to 0 within one period of oscillation. This is wrong because damping is quite low, so amplitude would not decay with such high rate. Now the oscillation frequency does not changes with time. The energy transferred from the oscillation is as quickly as possible. This is also wrong because energy transferred would be very slow due to damping, and oscillation frequency will be equal to the undamped oscillation frequency. And option B says that oscillation frequency does not changes with time. So we know that the oscillation frequency in damped oscillation, which is obviously lightly damped, does not changes with time. So the correct answer will be B and D will be wrong. Okay. So now let us move on to the next question. In this question, you can see that there is a planet of mass m which is in a circular orbit of radius r, which is around a star. The orbital speed of this planet is v, and there is a second planet of mass 2m that is revolving around the same star in a circular orbit of radius 1.5 r. So we have to find out the orbital speed of the second planet. We know that orbital speed is under root of gm by r, where r is the radius of orbit and m is the mass of the star around which this planet is revolving. So in this question, you can see that the initial planet was having a mass of m and the second planet has a mass of 2m, but orbital velocity does not depends on the mass of planet, so it would not alter due to the change in mass, but the radius of the second orbit is 1.5 r. So it is 3 r by 2. So obviously the velocity of the second planet would be under root of 2 by 3 v, because v is inversely proportional to root r. Uh, Okay, now let us move on the next question. In this question, you can see that there is a charge plus q and there is a charge of plus 2q that are at a distance of 3x apart from each other. The point P is on the line joining the charges at a distance of x and at a distance of 2x from the other charge. What is the electric field at P? So obviously we can say that the electric field due to Q will be kq by x square, and the electric field due to 2q will be 2kq by 4x square. So it is kq by 2x square. So the net electric field will be this minus this. So the net electric field will be towards this side because this is the bigger one. So towards right side, and its magnitude will be kq by 2x square. So the correct answer will be B. Okay, now we move on the next question. In this question, you can see that there are two bar magnets that are held in place in such a way that their north poles are facing each other. So which of the following diagram represents the correct magnetic field lines? We know that magnetic field lines originates from north and it terminates on south outside the magnet. So the correct field line would be option C. Okay, now we move on the next question. There is a pair of parallel conducting plates that are separated by a distance of 50 centimeters. These plates are separated by 50 centimeters. The electric potential of one plate is 200 volt and the electric potential of the other plate is plus 450 volts. A proton travels from 200 volt to 450 volt plate. What is the electric field strength between the plates and what is the change in kinetic energy? See, first of all, let us analyze the situation. We know that this is the situation in which the two plates have different charges on them, like this. Okay, let's suppose it is Q1 and Q2, Q1 and Q2. So when we distribute these charges, then we say that the outermost surfaces would have Q1 plus Q2 by 2, and accordingly we place the charge on the inner surfaces. So in this situation also we will do the same thing, but we will do this thing for potential, not for charge. So let us do this thing for potential. So we can say that the potential of the first plate is 200 and the second is 450. So the sum of these two is 650. And if we divide 650 by 2, then it is 325. So the potential on the outermost surfaces is 325 of the both plates. The potential at this surface will be minus 125 and potential on this surface will be plus 125. So you can see that the sum of these two is 450 and the sum of these two is 200. So you should always remember the fact that first of all, electric field is in this direction and the difference of potential is, now electric field will be dV by dx, and this dV is the potential difference due to bounded one. So the bounded charges are this and their potential difference is 125 minus 125, which is 125 minus 125 divided by the distance, and the distance between the plates is 50 centimeters, so in meters it would be 0.5. This would be 250 upon 0.5, so it is 500. And the change in kinetic energy of the proton. Now this proton is released, it is going from this plate to this plate, and proton is going against the electric field, therefore it would be retarding, and therefore its kinetic energy would be decreasing. So we can say that the change in kinetic energy of this proton would be negative, and the correct answer would be B. Now let us move on the next question. In this question, question number 25, this diagram shows the possible path Q, R, and S of the particles that are moving in the region of uniform magnetic field. The magnetic field is directed inside the plane of this screen. So we have to choose the correct option regarding these particles. So we know that first of all, if we have projected all of them in this direction, and if we analyze the direction of force by using Fleming's left hand rule, then we can say that the force, this charge Q will be the positive one, this charge S will be the negative one, and this R will be neutral because it has passed undeflected. So R will be neutral, Q will be positive, S will be negative. So Q will be proton, R will be neutron, and S will be electron. So the correct answer will be A. Now let us move on the next question. In this question, you can see that there is a circuit in which there are two parallel conducting wires which are connected with a cell, and there is a rod which is placed on these wires such that it can move freely. The length of the rod is L and the system is in horizontal plane. The magnetic field is coming out of this plane, and initially the current in the circuit was I, and rod is moving in this direction with velocity v. So obviously the force acting on the rod, this is the magnetic force, this is I uh, LB sine 90, and this force will make the rod move in this direction, and the current would be flowing in this rod in such a way such that it would be moving in the upward direction. Okay, so like this current will flow, then the force will act in this shown direction. So the correct answer would be A, that current is in anti-clockwise sense, and the force is BIL sine 90. Now let us move on the next question. In this question, you can see that there are two parallel wires X and Y that carry same current. There is a repulsive force acting between the wires. So we first of all see the scenario that when these wires carry the current in different directions, opposite directions, the force is repulsive and current is same, I. So F will be equal to mu naught I square by 2 pi d. This is force per unit length, dF by dl. Okay, and now what we have done, that the current in both the wires is reversed. Okay, current in each of the wire is reversed. So again, still this current will be flowing in the opposite directions in both the wires. Therefore, we can say the force acting between the wires will still be repulsive in nature. Okay, now the current in X is doubled. So one of the current is doubled and one of the current remains the same. And the separation between X and Y is also doubled. So dF by dl will be mu naught into 2I into I by 2 pi 2d. So cancelling this 2 with 2, we can say that force will remain same, force per unit length will remain same, F, and the force will be repulsive. So the correct answer is A. Now let us move on the next question. Now in this question, a horizontal conducting ring is perpendicular to a uniform magnetic field. So let us draw a ring. It is perpendicular to a uniform magnetic field. Okay, so let us consider the magnetic field like this inside the plane. This ring, when this ring is rotated by 180 degree about the horizontal axis, this is the horizontal axis, and the average EMF induced in the ring is 2 microvolt. So the area enclosed by the ring is this, and rotation takes 2 seconds. So what is the magnetic field? We know that the average induced EMF is change in flux upon time taken, and it is 2 microvolt. So 2 into 10 raised to the power minus 6. Now flux is B into A, and when we have rotated this coil 180 degree, then the change in flux will be 2BA, and the time taken in rotation is 2 seconds. Okay, so cancelling this 2 with 2, so B will be equal to 2 into 10 raised to the power minus 6 upon area of the ring. So this is 2 into 10 raised to the power minus 6, and this is 4. Centimeter square can be converted into meter square, so it would be minus 4. So this is 1 by 2 into 10 raised to the power minus 2. So this is 0.5 into 10 raised to the power minus 2. So it is 5 milli Tesla. So the correct answer is B. Now let's move on the next question. In this question, you can see that there is a rectangular coil uh, that rotates at a constant angular velocity, and at this instant shown, the plane of the coil is right angle to the line ZZ dash. A uniform magnetic field starts to act in YY dash. The variation of EMF is shown. The coil, what coil rotation about the axis produces this graph? See, first of all, we know that the angle rotated by the coil is only 90 degree, because we know that in one complete rotation this graph would have one complete cycle. So the one complete rotation has an angle of rotation which is 2 pi. So in one quarter cycle it would be pi by 2. Now we know that the initial EMF is maximum. We also know that flux phi is B A cos omega t, and EMF is uh, B A omega sin omega t. So initially you can see that EMF is maximum. So initially sin omega t is maximum and omega t is pi by 2. So initially flux is 0. So the magnetic field is in YY dash direction, this direction, and the coil is having these magnetic field parallel to its surface, which means that initially flux of this coil is 0. But when it has rotated by 90 degree, there should be maximum flux linked with the coil. So obviously the rotation of the coil should be along XX dash, because if coil rotates about the axis YY dash, then the magnetic field will be parallel to its plane in all the orientations. But if it rotates about XX dash, then after rotating by 90 degree, magnetic field will be perpendicular to the plane of the coil. So the EMF will become 0. So we can say that the correct answer is A. Now let us move on the next question. In this question, you can see that there is a magnet which is attached to a spring which oscillates above a coil, and the time period of oscillation is t. This graph shows the variation of variation with time t in the current induced in the coil. So this is I versus t graph. Okay, now we have to choose the correct option. The amplitude of magnet's oscillation is now decreased. Now what will be the I versus t graph? See, first of all, we know that on decreasing the amplitude, we can say that amplitude is the maximum displacement of the magnet from the mean position. Okay, and the EMF uh, is minus d phi by dt. Okay. Now the peak amplitude of the current depends on the peak amplitude of the EMF induced in the coil. And we know that when the coil will have the maximum velocity, in fact, when this bar magnet would have the maximum velocity, then EMF would be maximum. So V max would be uh, equal to A omega. We know that. Because you should always remember the fact that EMF depends on the rate of change of flux. So we can say that when this bar magnet would be at the lowest position, or we can say that it would be at negative extreme, then the flux linked with the coil will be maximum. But in that situation, EMF would be zero because at that position velocity is zero. So flux rate of change of flux is zero in this position. But when the velocity of the coil, when the velocity of the magnet is maximum, then EMF will be maximum and current will be maximum. So if we decrease the amplitude of the oscillation, then obviously the EMF and the current will decrease. But obviously frequency and time period would remain same. So the correct option will be D. Okay. Now we move on the next question. Now, gases in atmosphere are compounds of these four molecules. In fact, these four atoms. Now, four of these gases. This is carbon dioxide, nitrogen dioxide. This is methane, and this is water gas. A pure sample of each gas is produced. Each sample has same volume, pressure, temperature. Which of the sample has the smallest mass? So the volume, pressure and temperature is same, which means that number of moles is also same. Okay, so the smallest mass, if number of moles is same, then m by m is constant. Then we can say that m is proportional to m. So we know that the smallest mass of the gas would be methane. So the correct answer would be A because the molecular mass of the methane is smallest. Now let us move on the next question. In this question, you can see that there are some transitions between the energy states of an atom are shown, and we have to find out that which transition will emit the photon of the longest wavelength. We know that h nu is equal to E2 minus E1 or E final minus E initial. So nu is C by lambda. So we can say that the lambda is inversely proportional to delta E, which means that for longest wavelength, the difference in energy states should be least. So the least difference of energy state is E4. So we can say that the correct answer will be D. Now we move on the next question. In this question, you can see that in Gregor-Madsen-Rutherford experiment, alpha particles are accelerated to a potential difference of 7.7 megavolt and they are incident on a thin gold foil. The proton number is 79 for gold foil and we have to find out the distance of closest approach. Now we know that the alpha particles are, let's suppose this is gold foil. This is gold foil. And alpha particles are accelerated from infinity. Okay, so the kinetic energy of the alpha particles will be Q into V. And Q is 2E and V is 7.7 10 raised to power 6 volts. And this kinetic energy finally becomes zero because at the closest approach distance it would stop d minimum. So final kinetic energy is zero and initial potential is 0 and final potential is plus K into 2E into 79E divided by D minimum. So 2E into 7.7. Now what we are doing, we are equating the change in kinetic energy to the change in potential energy. So 2E into 7.7 into 10 raised to power 6 is equal to K into 2E into 79E by D minimum. Okay, so we can cancel out this K with K. So D minimum will be equal to 79 KE by 7.7 into 10 raised to power minus plus 6. Okay, so the correct answer will be option number C. Okay, now we move on the next question. In this question, you can see that in two experiments, X and Y measurements were made for the kinetic energy of photoelectrons that are emitted when light is incident on two different metal surfaces. Now graph shows the variation of kinetic energy with frequency of incident photons for both. What we can deduce about the experiment Y. So we know that HF is work function plus kinetic energy. Okay, so we can plot the graph. So E kinetic will be equal to HF minus W. So this is a straight line which is shown in the figure. Now the surface, we can also see that the y-intercept of uh, this graph will be less than this graph. So the y-intercept is W naught. So the magnitude of W naught y is greater as compared to W naught x. So we can say that the surface has y surface has the small work function as compared to the x. Y surface has large work function as compared to the x. So B option is correct. Okay, and the intensity of the incident light is less in the experiment. We cannot predict anything about the intensity in this case. Okay, because this is a graph between kinetic energy and frequency. Okay, so B option is the correct answer. Now we move on the next question. Now in this question, the intensity of electromagnetic radiations incident on a surface is I. The wavelength of radiation is doubled and the number of photons incident per unit time per unit area is doubled. What is the new intensity of radiation? C. The intensity of radiation is photon flux. This is the photon flux which we call as number of photons striking per unit area per unit time into hc by lambda, energy of one photon. So now what we have done, that wavelength is doubled, this is doubled, and the photon flux is also doubled. So the intensity will remain same because 2 will cancel out. So the correct answer is B. Now let us move on the next question. In this question, you can see that in a fusion reaction of one nucleus of H2 and one nucleus of H3 converts a mass of this into energy. And in a fission reaction, one nucleus of uranium 235 converts a mass of this into energy. So what is the energy released per unit mass of hydrogen and energy released per unit mass of uranium? See, first of all, energy released in fusion is this m, which is 0.024 into c square. We are ignoring this unit conversion because it would cancel out. And energy released per unit mass, in this case U1, will be equal to E1 upon total mass of hydrogen involved, which is 5. We are considering the mass number. So it would be 0.024 C square by 5. Okay, so this is. Now E2. It is 0.48 into C square, and U2, energy per unit mass, is 0.48 C square by M. The mass of uranium involved is 235. So U1 by U2 will be 0.024 by 5 divided by 0.48 divided by 235. It is approximately 2.35. So the correct answer is C. Now let us move on the next question. In this question, there are three statements about the gamma radiations. First one says that it travels faster than beta in vacuum. The second one says that it has a, this is obviously correct because the speed of gamma is equal to the speed of light because they are photons. Second says that it has a greater penetration ability than beta, obviously because the least mass is of gamma particles and they are having no mass because they are photons, so their penetration ability is greatest. Okay, and the greater ionizing ability than beta. This is wrong because the charge on gamma is 0. So the ionizing ability depends on the charge. So charge is on beta and charge of gamma is 0. So we can say that the third statement is wrong. So the correct statements are 1 and 2, and therefore the correct option is A. Now in this question you can see that pure sample of 4.4 gram radon has an activity of this. So what is the decay constant of radon? We know that the activity is lambda into n. So activity is 2.5 into 10 raised to power 16 becquerel. This is lambda, and n is 4.4 divided by 222 into Avogadro number. This is number of moles and Avogadro number. If we multiply number of moles with Avogadro number, we would get the total number of atoms. So lambda will be equal to 222 into 5 by 2 into 10 raised to power 16 divided by 4.4, and this is 6.023 into 10 raised to power 23. And the value of lambda will be approximately 2.1 into 10 raised to power minus 6. So the correct answer will be C. Now let us move on the next question. The moderator in the nuclear power station, what does it do? In option 1, option A says that it increases the proportion of U-235 in fuel source, transfers the internal energy of reactor to the turbines, allows operators to regulate at the rate of power production and decrease the kinetic energy of neutrons in reactor. Obviously, D option is the correct one. We know that moderator moderates the kinetic energy of fast moving neutrons because fast moving neutrons are not suitable for producing fission. So we have to slow them down. So the work of the moderator is to slow down the fast moving neutrons. Now in this last question you can see that the star y and x and y have same surface temperature. X has the radius r and the is at a distance of d from Earth. The distance of y from Earth is d by 2. The apparent brightness of y is double as compared to x. What is the radius of star y? See, first of all, we know that the apparent brightness B is proportional to the power received on Earth. Okay, or we can say the intensity received on Earth. And the intensity received on Earth will be equal to the power radiated, which is sigma E, because E is 1 because stars are ideal black bodies. So sigma A T to the power 4 divided by 4 pi d square, where this d is the distance from Earth. Okay, so if we compare the brightness, so Bx upon By will be equal to area of the star is 4 pi r square. So it is r square divided by d square, because t is same. It is given in the question. So the radius of x is r, and this is rx upon dx, and this is ry upon dy. So dy, the distance of y from earth is d by 2. So this is d square by 4, and distance of x from earth is d. So this is d square, and this is ry square. Cancelling d square with d square, and the brightness of y is double of that of x, so it is half. So ry square is equal to r square by 2. So ry is equal to r by root 2. So the correct answer is B.